Hello everyone, welcome again to another series of video from Electronics Eternity. Uh, it's been some time since I've uploaded a video, so I've been busy with my work and also studying, as I do my own research and development. So, uh, so I hope everyone is in the pink of health, and it's already December 2023. So, time flies, so. All right, so without further ado, let's jump into what we're going to do today. So what we're going to do today is basically processing information from char array, right? So I find this very important because char is basically a data type that is very small in terms of its size in comparison to string or float or whatever, right? So basically, char is very small in terms of size, and therefore I feel it's effective to do, to make use of it instead of going for string, right? String is usable. There's nothing really wrong with string. It's just that string is a bit bigger in terms of size, and therefore if you're trying to make your code as efficient as possible, it would always make sense to use the smallest data type. So in this case it's char, and when it comes to char is always a single character. So if you're processing it in a form of array, it gets a bit complicated. So which is why I thought of doing this video so that we all could learn from this, and hopefully it could help in whatever you're doing. All right, so what I have over here is a code that basically portrays how we can, process char arrays, and how we can take information out of it, or how we can identify a particular character and subsequently produce the outcome that we want, right? So in this case, what we're going to do is we're trying to take some input from the serial monitor, and we are going to use that as our IP address, right? So it's a simple example, that I could relate. It can be, in my case, it's IP address. In your case, it could be a string with whatever prefix or suffix. It could be an ID. It could be an identifier or whatever, right? So the point is, hopefully through this video, I will show you methods on how to do this, and you could, right. So let's look at the code. So basically, I need to thank this person for coming up with the basics of this code. I kind of like uh, took the idea from his code, and then I changed it a lot. So if you can see, there's a lot of changes. I did not take the code directly and just copy paste it. So, but the idea is taken from this code, and therefore I would like it to be there, right? So that people know that I'm not just simply copying anyone else's effort. All right. So what we have over here is we have a integer, which is a constant, and it's an unsigned value. That means it doesn't have positive or negative. And the value is 15. The reason why the value is 15 is simply because in my IP address, the maximum character could be this, right? Which is in total 15 characters. It's like 12 digits and 3 dots, and therefore it's 15. So I think it should be 16 because I would like to have my last character, as the nullifying character, and therefore it has to be 0, right? So it needs to be 16. So let's keep it like this. Next is we have a boolean called string match. If string match is basically a function which tells whatever we get from the serial input is acceptable or not, right? So that's why I said it's string match. So the original value is going to be false. Over here, we're initiating a serial communication. Next is we are going inside the loop, and the loop is going to run string match for as long as the value is false, right? So if it's true, then it will probably break the loop. It's just simple idea. So maybe once it breaks the loop, then you can progress with the next part of your code, which says do something else, right? Okay, so that's just the idea about it. Now let's go to the function string return. So it's a long code over here. So we have void string return starts from here and then it ends over here. So the big part of the string return is while serial available, which starts from here and then it ends at the the second last curly bracket. So everything is inside while serial is available. It's not going to do anything if we don't receive anything in the serial. For example, if we don't key in anything. All right. So first, declaring this variable is going to be static because it's a local variable, and it's a char called message. How many characters is what we define over here, which is 16, and message is going to have 16 arrays, which includes the last terminating character, which is 0. And then we're going to have static unsigned message position. So this is basically the message position because, as I've said earlier, char is a single character. If you're going to have a lot of it, you will need to position it so that you can append to the array. So in this case, the char array is message. This is the position. It starts from 0 and then it will go all the way up to 16. All right. And so we have char, and then this is basically a buffer. So it's going to read and it's going to store the value in the buffer. So let me just write buffer over here. So it basically, so that is the first declaration of variables. And then we're going to start looking into what we're going to do once we receive something from the serial. So basically, if inbyte does not equal to new line, which is the next line, right? And the message position is less than 16. In this case, it's 16 minus 1. The reason why minus 1 is because we would always want to reserve the last position as for the terminating character, which is 0, right? So if it's less than 15, then whatever value you take it, you put it into message, and this is the position. It's going to start with 0, and it's going to increment from there onwards. Okay? So for as long as it's less than 15 and the value is not a new line, it's going to keep doing that because serial reads every single array of characters one by one. So it's not a serial read string where serial read string will read the entire string at one go. However, serial read will read each and every character in an array. So for as long as this condition is met, it's going to keep storing the value until the buffer is fully filled, right? So which is 15. So else, if it's already enough 15, right? And sorry, it's less than 15, my bad. It's actually less than 15. It's not equal to, it's less than 15. And the value is not slash n, which is a new line, right? So it's going to keep storing that. So whenever it detects this new line, it's going to go to the next part of the if, which is the else statement over here. So when this condition is broken, sorry, this condition is no longer met, then it will go to the next one. It will take the message position and it will assign the last position to a terminating character, which is slash 0. We need this terminating character to tell the compiler that this is the end of this array of char, and we're going to go to the next one. Okay, uh so message position, and it's going to keep adding until we reach a point where we find a new line, and so the last character will be 0, and what we're going to do is we're going to take the whole value and we're gonna print that value out. Just to give us a picture on what we actually insert is what is received and read. Next, we're gonna declare a variable over here. It's called Boolean. You think, let me try to put this as static. It should be static as well. Let's see if it works. So the reason why I'm using static because it's a local variable. I don't want it anywhere else in the function. Just some good practice. So we're gonna check if whatever we receive is a number because IP address is always a number, right? It's a number followed by dot and a number. So if it is a number, then it's gonna print the input number. Input is a number, and it's gonna change the Boolean value to true, right? So maybe in the beginning we can set it to false, so that it changes after that. So if it's true, then it will change the value to true. If it's false, then it will remain as false, right? So this is basically some validation that we're doing over here because what we want from the serial monitor is an IP address. And IP address are always numbers. So if we receive alphabet, then we would know something is wrong. So this is the first level of information processing. So the next is what we know about IP address is IP address would have three dots, right? So we're gonna start calculating, we're gonna start going through each of this array, and if it equals to dot, then we're gonna add to the count, right? It's gonna start with 0 and it's gonna add to count. So let's see how many we get, right? So, and then the next part, I think this is the last part of the validation. So again, we have another variable being declared over here. There is no negative and positive sign to this, and it's a minimum IP length. So the reason why it's minimum is because from where I'm from, the IP would always be, in this format, right? So this is basically the shortest of IP address one could have. And therefore, that's why I said minimum IP length is 11, and the total of this is basically 11. 3, 6, 8 plus 3 dots is 11. Okay, so what we're going to do whenever we receive an input is we're going to see if it's correct. So the first way to say our IP address is correct is to see we have 3 dots. Remember this function that calculates dot over here? So we're going to make sure it has 3, nothing more, nothing less. And the string length is more or equal to 11, right? So it has to be at least 11 or more. And then it has to be number. So we remember we have a function over here that basically validates if the whole entry is a number. So if it's true, then we basically have attained our our IP address in the serial monitor. If it's not, we're going to say IP address wrong, try again. Number of dots in the input is, whatever number that we got. And from here, we already tell that this whole thing is a number or not, right? So that's the end of it, right? And this is the message position. We're going to set this back to 0 because whenever we receive the next input, we want to start from 0, and the count needs to be refreshed as well because we want to start from 0, right? So I have already uploaded the code, but then, just for the sake of the video, I will upload it again just to prove to you that this whole thing works. Here we go. What do we have over here? Else too many decimal point. Oh, my bad. I could have another one over here. Okay, so hopefully nothing goes wrong. So it's compiling, looks good. And we're gonna hit the boot button as we see connecting. Okay, now we'll let it go and it's uploaded. Okay, so now let's go to serial monitor and let's just type in some gibberish over here. And you see the message keyed in is this FSAF and the input is not number, the IP address is wrong. Try again. Number of dots in the input is 0 simply because there's no dot over here. But what if I say fa.fa and then I enter this? The message key in is FA. The input is not a number. IP address is wrong. Try again. Number of dot in the input is 3 because we have 3 dots. Now let's even test this further. You see, the input is 192.a.15.a. So the reason why it says the input is number, it's basically because it checks the first value and then it assumes that it is number. So if you want it to be really critical on this part, then what you could do is you could incorporate an for loop over here and go through each character and see if it's a number. So that's one way of doing it. Over here, if the first 3 digits is a number, then it basically takes that as a number. You see? But then, just for some basic validation, I think this would work because how dumb a person has to be to key in this as an IP. But then there could always be chance for, typing errors and stuff. But ultimately, it says this whole thing is wrong, right? The input is a number, IP address wrong. Try again, right? So let's see. Okay, now what happens when we actually input something correct like this? So you see, the message keyed in is this. The input is a number, IP address is obtained. So this is when we basically got the IP address and the purpose of the function is fulfilled. So let's try something else again, just for the sake of experimentation. So it still says the input is a number, IP address obtained. So in this case, it's kind of wrong, you see, because the numeric validation has basically failed, and then it says input is a number, IP address is obtained. Right, so I hope I know that this is not perfect. You can actually further drill down on this and then fortify the part where you verify each character and to make sure it's a number. You can do that, but then I'm not really too critical about it because as long as someone enters something like this and it's enough for me, and the function could identify that this is a wrong entry, this is not an IP address, and it's wrong, right? And therefore, it's enough for me, right? But if you want it to be perfect, you can always add further validation to it and then fortify it. Okay. Now, another one point, if you notice, this function keeps on running, right? So even though the IP address is obtained, so one way you could make it stop is you could take this over here, and whenever IP address is obtained, you just set the value to true, and then it would break it will break the function. So let's just try that, and then we say serial like that, serial print line. Uh, let's say yeah, IP address is obtained, right? So let's upload this. Just to show that I'm going to hit the boot button as I see connecting, and it's uploading. We're done. So let me clear the serial monitor, and then I'm going to type in some gibberish. So IP address is not obtained, and then I'm going to type in some gibberish again. It's not obtained, and then finally I'm going to insert some correct IP address, and you see number of dots, the message keyed in, IP address obtained. But something is wrong over here. It does not say serial print yay IP address is obtained. Oh, it keeps on running. Something must be wrong over here. Let's see what it is. Ah, it should be true. Man, that's some critical error. So it should be true. So let's upload the whole code again. And I wish this thing can be faster. Okay, uploading as usual. So let's clear and then put some gibberish. We're not gonna get anything. Gibberish again, we're not gonna get anything. And then we're gonna, right? So finally, let's key in something correct. Uh, maybe one fine. See, it says, yay, IP address is obtained. And it's running the same thing again. So basically, after this, if you input something, I don't think it's gonna work. Let me toggle the auto scroll. Let's go down. So that's it, right? So you could, if you really want this to run once, I think you could uh, copy paste this and then put it here, right? So it will be in this while until it breaks the condition, and then you won't get this repetition of a serial IP address obtained. Let's just upload that and then try. Hit the boot button. Okay, it's uploading as usual. Okay, so let's clear this. Okay, again, some gibberish, and then it says this is wrong. Some gibberish again, and then finally the correct value, 0.7. So message is keyed in is this, the input IP address, yay, IP address is obtained, and we only get this once, right? So basically you can run this once if you needed to run it only once, because whenever you're trying to gather an input from serial monitor, you won't be doing it every once for 1 second, so you won't be repeating that. It's always some setup that you do at the first. You only need this kind of entry once at the beginning of the program, right? So if you put it this way, it's only going to run once, right? So you can change this, you can take this out if you don't want it to run only once, or you want it to run forever. Whichever way you need it to work for you, you can customize it according to your need. Right, so with that, we have come to the end of the video. I hope this gives you a picture on how you can manipulate your char array processing to get the desired output so that it works for the function that you're trying to develop, right? So I hope you learned something new. Thank you for watching. Please don't forget to like and subscribe. Until we meet again. Bye-bye.